Hey everyone, welcome to today's video. People often say TCP is reliable. Whatever you send, it gets delivered. And yeah, that is absolutely true. I'm not denying it. But there is something about TCP that nobody really talks about. TCP being reliable does not mean your app will be fast. Things can still go wrong. And your monitoring system cannot tell you the real reason behind the failure. So what actually happens? Let's say a packet gets dropped and TCP just keeps on sending it until it is not delivered. But all of this happens quietly in the background. While your app does not see an error, your logs don't show you anything, and from the outside, everything looks just absolutely fine. But underneath, your app is actually waiting a bit longer than usual, and that wait keep on increasing your latency and your request starts getting slower. And after some point of time, you get timeouts within your app. So this is a tricky situation where nothing clearly breaks, but your system is already struggling due to that drop in packet. So in this video, we will break this down step by step and we will see what really happens when a packet gets dropped and why your metrics don't show you anything. We will learn 3 simple commands which you can run on any Linux server to check if this is already happening with you or not. So without any further delay, let's jump into the topic. So this video, we will try to segregate into multiple steps. At the first step, we will try to understand how a normal TCP flow works in production or in a normal communication. Then we will understand what happens when a packet actually gets dropped. At the third stage, we will try to see our scenario or the use case which we have built to create an artificial drop in packet. We will try to understand how exactly it has been designed. Then we will try to create a scenario where we will inject an artificial delay or drop in packet and we will try to debug it. We will understand how you can debug it and what should be your mental model when you are debugging a packet drop scenario. After that, we will fix and confirm how exactly the system is looking before the packet was dropped and after it is fixed. Finally, we will understand how exactly the big tech giants track the packet drops within their application or within their system and how we can learn it to implement within our system. So let's see it in action. So how the normal TCP flow works. So whenever two systems talk to each other, the message which is being sent from the sender to receiver are getting divided into multiple packets. Your message gets divided into multiple packets. So what are these packets? So these packets, you can consider it as an envelope, and within this envelope, your data is sitting. So the main job of TCP is to track each and every packet which is getting transmitted within the network from the point A to the point B, or in your case, service A to service B. So how exactly the communication happens? So as you know, TCP sends the packets one by one. So, and it tries to give a numbering so that it can track the delivery of the overall packets which is being sent from the sender to the receiver. Let's say this is packet 1, packet 2, packet 3, packet 4. So once a packet 1 is being sent to a receiver, receiver gives an acknowledgement to the sender that I have received the packet 1. And once it is being sent, that we call it as ACK, as you know, right? So in between, let's say it has sent packet 1, packet 2, and after that it has sent packet 4. Immediately, TCP or the receiver will send a signal to your sender that I have not received the packet 3. Please resend it. So during that time, what sender will do is it will try to find where it has been lost. Can I send it? Once it is found, then it will resend that particular packet, which is in our case, the packet 3 to the receiver. It looks simple, right? But in real scenario, it is not the case. What exactly is the problem? So whenever a packet gets dropped, for example, in our case, if packet 3 is getting dropped and the communication is lost, TCP re-establishes a connection to find that particular packet 3. And once it finds, it tries to send it. So let's imagine your application has a timeout of 300 milliseconds, and in between the communication, there is a single drop in packet, which has taken almost 400 milliseconds to retransmit. So that delay or retransmission of that packet can create a timeout in your application, which happens most of the time. And this timeout is not for your bug in the code, or it is not for your database is slow, or not your query is not fast enough. It is due to this packet drop, which is kind of an invisible problem, but it can create the problem which cannot be visualized immediately. And whenever you will be trying to debug it, you may be looking into your application, you may be looking into your network, but most of the time you always forget about the network, which can create this timeout, which kind of a dangerous situation. So we will try to see how you can debug in the real scenario. So what is the setup we have? So for this scenario, what we have done is we have created 2 VMs in our AWS environment, and one of the server is called as the sender, who sends the signal or sends the traffic, and there is a receiver who opens port 5201 And we will be using a tool called iPof for opening the traffic for the world or within the network to send any signal to that particular receiver. And for this illustration, we will use 4 different types of commands or 4 different types of tools for the effective debugging or effective troubleshooting for a packet loss problem. What are these? One is your iPof 3, which used for measuring the network throughput between a point A to point B. The second command is your TCP dump, which we have seen in our TCP video as well. If you have not seen it, then please watch it. There will be a I button which you can click to see that video. So what exactly does it? It watch the actual packets on the wire or over the network, how exactly the handshake is happening and how exactly your signals are, or how many ACK or SYN-ACKs are being received within your TCP. The third command which we will see is the iProud2, which is a tool chain, and from it we will use a tool called TC to inject a artificial packet loss. And finally, we will use a utility called nettools, from which we will use a command for netstat to see the TCP counters in real time. So these are some of the powerful tools which we will use it for the illustration, and we will try to debug our packet drop problem in real time. So let's see it in action. Before we break anything, we need to take few readings to understand how exactly your system is behaving at a normal stage. Why it is important? Because before you break anything, you need to understand how your system is behaving and what are the normal behaviors or signals your system is giving before it goes into a broken state. So we try to take the readings at the 3 baselines, which we call. First baseline is your user experience. We need to understand at the user layer how things are functioning. At the second layer, we need to understand how the network layer is functioning, where we try to see the TCP behavior. We try to see what are the TCP packets, how much transmission has happened, how many drop of packet has happened, how many things are being transmitted, how many TCP packets are retransmitted, or how many duplicate acknowledgements has been received for the segments. All these things we need to track down. And at the file and baseline, we try to see the behavior of your hardware, or very specifically how your network interface card is behaving. And we need to track down all the readings before we break anything. So let's see how exactly it can be taken and how it normally sees. So before doing that, what I need to do is I need to start a receiver where I can send the traffic from a separate sender. So for that, what I will do is I will use a tool called iPof3. What it normally does, it start a traffic server, which tells the senders within the same network to send traffic on port 5201. It is a inbuilt tool of Linux, which can be used, which I felt it is good for my use case. So that is why I have used it. But in normal case, when you are trying to connect 2 services, it can be 2 different services which can be talking to each other. It can be 2 different servers where 2 services are running. It can be 1 database, or it can be 1 application servers which can be talking to each other. Multiple scenarios. But for my use case, this tool suits me best. So I have used it. There is no particular reason for it, or there is no particular use case which can be attached to your production scenario. It is totally out of context. For your understanding, you can consider it's a traffic server, which is letting no other host to send the traffic on 5201, any host within the network, right? So that is what my receiver has been set. Now I need to understand the baseline measurement, or take the baseline measurement first at the user level, which I mentioned. So what I need to do is I need to use a command, ping command, simple ping command. And what I will do is I will send exactly 20 packets, and I will try to see how the packets are getting delivered, whether the packets are delivered or not. If it is delivered, what is the success rate? What is the overall time it has taken for individual packet and the overall packet, and what is the RTT, or in long term, we call it as total round trip time. And I will try to note that timings for my future references. And I can see there are 20 packets which has been transmitted, and all 20 has been successfully received, and there is a 0% packet loss, and overall time is around 56 millisecond, which has been taken, and the RTT minimum is 0.248 millisecond, and the maximum is 0.843. I'll just keep it aside for my future reference. And I can see that my user layer is working fine. Now I will get into the networking layer. In the networking layer, I will try to see the TCP retransmit counters using the command netstat. So netstat is again a powerful tool which can help us to track down the TCP retransmission counters, and I can enter it, and I can see till now there are 552 segments has been retransmitted. It is not which is something happening in real time. It is the overall segments retransmission from the time the server was last rebooted. So if I want to confirm whether it is happening or it is just a ideal static behavior, I can run it for multiple times. If it is happening in real time, I can see that this counter will be increasing. For now, I can see there is no increase in the segment retransmission, and I can confirm that there is no packet drop which is happening at the TCP layer. I can be rest assured. Once I am done, then what I will do, I will get into the baseline of understanding how the packet drop, whether a packet drop is happening at the hardware layer or not. So for doing that, what I will do is I will use a command eth tool followed by my network interface, which is ENS5. For your case, it can be different. To know what is your network interface card, you can simply run ifconfig-a, or you can use ip-link show. I can give that in this somewhere, and you can keep it for your reference, and you can find out what is your network interface card, and you can graph for messages like drop, missed, or error, and you can hit enter, and you can see the baseline is almost 0 for this. And if it is 0, you can be rest assured. If it is not 0, then that is something you should be cared about, because if it is non-zero, then you can consider that there is some drop is happening at the NIC level, which is quite dangerous, and you don't want to be in that situation. For my case, it is 0, and I can be rest assured that there is no problem at the hardware level. Now, I will get into the layer where I will create a artificial ingestion of packet loss. How? I will use a command called as tc to inject a packet loss. So what I will do, I will inject a 20% drop in packet. Disclaimer, don't use this command in your production environment or in the environment where it is shared or serving any real traffic, because it can actually create a 20% drop packet from the network itself. So don't try to do it. Just keep it for your exercise purpose, which I am doing. Just follow it, not to be done at home. So now I have created an artificial delay in my packet delivery. Now I will track down where exactly the drop is happening and how my TCP is behaving. So for doing that, again, I will start from the user layer by using the ping command. And now I will see how the ping is behaving for the overall packet delivery. Total 20 packets I will be sending, and I will tracking down the time, what is happening now and what was the before. Let it run. So here I can see the transmission is good enough. The time is taken kindly same. It is not increased, but the O-ring factor is that out of 20 packets, almost 14 has been received and 30% packet loss, which has happened. Though I injected 20%, some point of time it has more loss has happened at some layer, and the timing is good enough, but there is a packet loss, which I can clearly see. So this will tell you the overall packet delivery, but it will not tell you the root cause why it has happened. It is a one counter which can take as a consideration for your reference, but not tell you that what is the actual problem. This is just a first level of debugging or first level of troubleshooting we try to see to understand how exactly it is behaving at the user layer. I can see there is almost 20%, which is not good enough. Then I will get into the second layer. What it is the TCP transmission or segment retransmission from the TCP layer or the network layer. For doing that, I will run the same command again. And here I can see the counter has increased to almost 569, which was almost 552 before. For reconfirming, I will rerun it a couple of times so that I can understand whether it is intermittent or it is keep on happening, because what happens most of the time is packet losses are intermittent issues. It cannot be tracked immediately until unless it is not a serious problem. For my case, this is artificially injected, so this has to be staying. If in your case, in your production scenario, if it has occurred for various reasons, if you are not able to track down by a monitoring system, you can see this transmissions or retransmission in your TCP. If it is keep on fluctuating or keep on increasing, you can surely or rest assured that there is some issue at the network layer itself. To see it in real time, what I normally do is I try to run watch command, same command with watch flag, and I try to see how exactly the segments it is retransmitting in real time. And I can see it is keep on increasing, and there is something which has to be worried about. And I can just keep it open so that I know how it is increasing or how it is decreasing, so that I can do further troubleshooting. Now I am assured that there is something at the TCP layer. Now I will go a little bit deeper into it by measuring the throughput, how exactly TCP is uploading any packet or how it is receiving all this behavior. I will try to track down. For tracking it down, I will again use ip-of3 command followed by the IP where the packets are being sent, and I will try to give a time for 30 seconds. So I will try to see for 30 intervals, and I will try to see how exactly the transfer is happening. So here, what are the things it can tell you is, it can tell you the interval, which is every second, what is the transfer size and what is the bit rate or the upload size, and how many retries happened for this particular transfer, and what is the C wind for this particular transfer. So here, multiple data which is there. You don't have to go very analytical or not need to try to see all the information. So as a good troubleshooter or good production engineer, our job is to see the signal and carve out meaningful information out of it. We don't need to go very deeper into each of the things. Surely you can go about it. There is no denial to it. But important thing is that to get the signals and understand what exactly is happening. From this output, what information you can get it is that you can see the transfer started nicely. It started at 896 kbs or kilobytes. The bit rate was also good, but the retries was too much. And the transfer rate was keep on decreasing. And here you can see almost it went to 0 for almost this many seconds. And after that, it peaked to 256 bytes. But again, it has dropped to 0 bytes. And again, it started 256. And there is a pattern which is keep on fluctuating. From this, what you can understand is the TCP is slowly reducing your throughput, which means the upload rates are keep on decreasing, and slowly your system is getting into pressure, not at the hardware level, but at the network level. There might be some congestion which is creating, and it is not good for a healthy system, or a healthy system should not be in this position. And this throughput is very important when you are debugging your packet drop, because the packet drop can cause multiple issues. But if your system is not healthy or getting into a state, into an unhealthy state, that is something you don't want the systems to be in. And immediately you should take actions. Either you can reach out to your network team, or you can reach out to your network hardware team, or whoever is managing the vendor, so that you can tell them that, okay, this is the counters, these are the outputs which I have received from my terminal or from my troubleshooting. Please debug it, or try to fix it as soon as possible. Because if this is happening, then until this time, your app might be seeing a lot of retries. There might be high latency spike, which might be happening, or multiple issues which can happen. And this is the ideal output which you can get for getting into the root cause or getting into the actual problem which is happening. As a final note, I will just check the network interface card behavior using the ETH tool, and I can see there is no problem at the hardware layer, and whatever is happening at the network layer itself. And I am surely at this point of time, I should get into my networking team if there is any. If not, if the networking infra is being controlled by me, then I can take the necessary actions, or I can reach out to my internet service provider. If there is a congestion in network is happening, then I can go and ask them for help. Or if I can do some troubleshooting, or some things are in my hand, then I can do it on my end as well. So for stopping this, what I will do is I will just remove the packet loss rule, which I just applied, and I will hit enter. And again, I will try to rerun the baseline commands to see if it has fixed or not. I will just run the same ping command to see how exactly it is happening. And once it is run and I confirm that it is being fixed and all the packets are delivering in time, then I will just again check at the TCP layer. I will run it for a couple of times and I will see whether it is happening or not. Same thing I can see in my other terminal as well. And I can see it is quite static, and I can assume that the issue has been fixed now. Now you might be asking, what are the other scenarios, or what are the actual causes which can create the packet loss in real time in my production? So there can be multiple scenarios which can create packet drops. One is your queue overflow, which is the number one cause in production, which happens most of the time. What exactly happens in that? So maybe your packet will be arriving faster than they can be processed. Maybe there you will be having a size or buffer queue which will be filling up fast. And if a packet is arriving, it cannot be processed. During that time, packet drop can happen. And that is an intermittent problem. It can go away or it may not, but that can also cause problem. And where it can happen in your router queues, it can happen in your switch buffers, it can happen in your NIC ring buffers, or it can happen in your kernel network stack, anywhere you can imagine, right? The second layer, it can happen in your network congestion. For example, if there will be too many flows in network, or there is limited bandwidth, or there is a problem in your network connectivity, during that time, your packet also can be dropped, right? The third thing can be within your NIC driver or kernel drops. It can happen maybe during whenever your CPU is getting saturated, or there may be small ring buffer which is happening, or there is a bad driver tuning which is happening. Many cases which can happen. And frankly, most of the time the things is not under your control, because there are multiple factors which can create a packet loss. But what you can do is always follow this 3 baseline behavior when you are troubleshooting, or you are feeling that there is a packet drop which is causing my app to fail. Because whenever 1% drop in packet is happening, that can drastically hamper your app performance. Your latency can spike up like unimaginably. So that is why troubleshooting or debugging it effectively makes more sense. Now you might be asking, what exactly you will get by tracking this? So when you try to track this efficiently, you then stop chasing other teams or bug other teams which they don't have the problem. Most of the time problem lies within the systems only. If you follow this mental model, or you understand this baseline effectively, then the debugging the issue is much faster. I have seen teams who have taken almost a day to track down or understand that the problem is lying underneath their network, not with other dependent systems. Because most of the time what teams does is they try to blame, or they try to track down other teams for tracking down the actual root cause whenever they are getting timeouts, or whenever their latency gets spiked up. So this debugging is very much important if you are trying to getting into any root cause of your timeouts. So now the question is, how exactly other companies do, or how the tech giants do handle their packet loss problem. So I have 3 scenarios which I have found. So first is your Netflix. So Netflix uses or tracks per float retransmit rates from their edge nodes. So they have their own edge environment, which they call it as Open Connect, which gets deployed at the internet service provider end. Again, that is a separate topic. We are not getting into that. So they try to track the per flow retransmission rates from their edge nodes. And whenever there is a specific path starts dropping packets, they reroute the traffic before any user notices it. And the signal they use is the same retransmission counter we just watched on the terminal, where we are using watch and we see all the retransmission packets. And whenever it is happening, they just retransmit to another edge server or another edge servers before user gets notified. So for AWS, they do a little bit different. They expose their NIC queue depth as a CloudWatch metric on EC2 instance. And if their queue is filling up or your queue is filling up for a particular instance or service, the packets are being dropped at the hardware level before the TCP even sees it. And that is the ETH tool counter, which we checked in the signal 3 in our example as well. The same thing, AWS also does it, but they try to expose it as a metrics in the CloudWatch metric for the EC2 instances. Finally, the Akamai, one of the, again, biggest CDN providers in the world. So what they do is they use interpop packet loss, which is their tier 1 alert. So if a packet loss between 2 points presence goes above a threshold, then it triggers a automatic traffic rerouting within their system. And the underlying system, which is there, it gives the same signal, and a packet loss percentage is being measured on the where, not at the application level, and they retransmit it to another location within the network. For a detailed understanding on all these configs which these giants are doing, there are documents in the description. You can follow it and you can read it through how exactly they do. And if you are trying to restructure your packet loss tracking, you can follow those models or you can develop your own as well. But every company has their own standards for doing it. Again, multiple security principles and network principles come into the picture. So it differs, right? So as a final note, I can say if this has helped you to develop a mental model for debugging a packet loss, and you have understood what actually is happening below your application level, then please hit that like button and let us know your thoughts and feedbacks and suggestions. We love to hear your thoughts. And don't forget to hit that subscribe button. It can help to reach our videos or contents to the persons who are actually trying to solve production level problems or trying to understand some concept at scale. So with that, thanks for watching. See you in next video.